Okay, so as we talk about the evolution of virtualization, cloud computing is really the next step. And cloud computing is the virtualization of infrastructure, platform, and services. And it really just depends upon what level of virtualization and what level of services are being offered to the end user. Okay, in a nutshell, it gives us automation and self-service. So in a cloud platform or a cloud environment, depending upon whether it's infrastructure, platform, or software, there is a level of automation and self-service, so a user can go in and perhaps provision their own virtual machines or provision their own databases, or they may be able to provision their own development environment, test their applications, spin up some type of test dev environment, or they may just go in and just start using an application. So it just really depends upon what platform we're virtualizing. So it's a reduced time to market. It also gives us an increased speed to develop our applications and deliver value to the business. All right, so cloud computing is made up of a couple different services, as I mentioned. We have infrastructure as a service, or IaaS, platform as a service, or PaaS, and then software as a service, or SaaS, All right, and there are a couple different variations of cloud computing. We have a private cloud, we have a public cloud, a hybrid, and then community. All right, I'll talk about each of these in a little more detail in just a moment. All right, collectively though, that's called the cloud. All right, that is just what the cloud is, and of course it means different things to different people, but in a nutshell, it is a virtualized infrastructure that provides some level of service, and it gives it in an automated fashion. All right, so along the same lines as I talked about before, we have this new kind of buzzword where it's X as a service, and you can kind of insert the buzzword as a service, whether it be software, it could be security, it could be storage, whatever, as a service. All right, so what we're doing is we're virtualizing and basically commoditizing almost every layer of the IT stack, right? And we're providing that quicker deployment and that increased HA or DR, right? HA is high availability, DR meaning disaster recovery. So we have the ability to spin up a number of servers. We talked about the VMware example previously, where we have a couple ESX clusters, right? Here we have a failed server in the middle. We have three different stacks, three different clusters, three different ESX clusters. We have a failed server in one. What we can do is simply move through something called vMotion. At least that's what it's called in a VMware infrastructure. We can vMotion off of the failed server onto new hardware, okay, onto a new cluster. So you can either proactively move things if you know you're going to maybe down a server for maintenance or swap something out. You can vMotion those clients off to other hardware. Or in the event of a failed server, you can have an automated process takeover where it will proactively move those over to more stable hardware. Now, as far as infrastructure as a service is concerned, IaaS, it allows for the distribution and consumption of resources as a service. So it's a multi-tenant environment. Multiple users can utilize the same infrastructure, and it allows for elastic scaling as demands increase and decrease. All right, so what does that mean? Well, we basically provide compute, network, and storage as a service. So to the end user, they want to go in and say, hey, I need a VM spun up that's running Linux, and it needs to have what have you, Apache. It needs to have web services, maybe MySQL or SQL or Oracle or whatever the case might be. I need all of these things spun up, but I don't want to have to spend the time to provision. I don't want to have to go through the process of going through some type of change management, getting IP addresses assigned, getting VLANs set up, getting all the things that typically accompany when we want to provision a server. All right, so when we do that as a service, infrastructure as a service, they're given some type of self-service portal, and from there they can go in, choose what they want, click a few buttons, and it kicks off a workflow. And that workflow then delivers and provisions that server. So it might be a few minutes later to a few hours or a few days, just depending upon the approval processes and so forth. But it gives a very automated fashion, or it gives that VM to the end user in a very automated fashion. Now, the other thing to keep in mind is it typically will change your pricing or your billing model too, because we now no longer have to go out and buy new servers. We don't have to go out and buy licenses and so on and so forth on an individual basis, right? In other words, CapEx. We now can switch that to OpEx, or operating expense. It's almost like a utility bill. So we can just pay a monthly fee. We want to use X number of services. We want to use X number of server, compute, network, storage. We just pay a fee, more or less a fixed price, depending upon how much we use. And there's no upfront cost to acquire the hardware first. All right, and again, that infrastructure, that cloud, can be public or it can be private, or it can be both, which is a hybrid model. All right, next we have Platform as a Service, and Platform as a Service, or a PaaS environment, is comprised of computational resources, and it's typically in a test dev environment. It can be easily configured, can be stood up very rapidly. So again, as I mentioned before, there's no need to go through all of these different things that are typically associated when we want to spin up or stand up new hardware. You don't have to order the servers. You don't have to acquire rack stack hardware, configure network and IP addresses, load balancers, VLANs, install software, etc., etc. All right, so when our development team or our test dev guys want to spin up an environment, they simply go in, click a few buttons, have it provisioned, spin up an environment very rapidly. They can go in, check out as far as their code is concerned, do their whatever testing they want to achieve. They can elastically spin out more VMs as needed, run their tests, automatically tear those resources back down again. And again, it's a multi-tenant environment where many users can share the same set of resources. A few example PaaS providers would be Amazon Web Services, or AWS. They have a service called Elastic Beanstalk. And again, that Elastic term, just so we're clear, it means it can grow or shrink depending upon the resources that we need. So if I have an application that typically, let's say for instance, it sits on 2 servers and it runs on a specific database, and it has X number of IOPS per day, per hour. It's a fairly consistent usage pattern for that specific application. But let's say month end or quarter end or year end, we do a lot more processing now. We're running reports that we have to maybe get out for a specific application or a specific user, or an executive report or so forth. We can elastically expand that out, maybe add 3 or 4 or 5 more servers, add more CPU, more network, and so forth to speed up the processing on that report. Along the same lines, we may have a web server that 9 times out of 10 gets fairly consistent traffic throughout the year. Well, at year's end or month end, or we might be running a special promotion or a commercial, or perhaps we have an ad that's appearing, during the Super Bowl or something. Well, we want to make sure we have resources in place that can accommodate all of that increased workload. So by using something along these lines that gives us that elastic capability, we can expand out as needed. Again, we don't have to have all those servers in place running all year long, just sitting idle. We can run with a lean, mean set of infrastructure for most of the time, and then as needed, expand out to accommodate all the traffic. And then when that's done, we can shrink back down again. All right, so there are a few others out there: Windows Azure, Heroku. You can read through the list here. There's a number of PaaS providers that make that acquiring and provisioning infrastructure very easy. Okay, next we have Software as a Service. And Software as a Service, or SaaS, basically applications that are provided on demand. So there's no setup, there's no installation or configuration required. You simply just pay for the use of that service, that web-based service, such as Salesforce, Office 365, Google Apps. Okay, just some examples of some players in that market. All right, so if you think about it, you want to use Microsoft Office 365, you don't have to go out and buy the software. You don't have to order servers. You don't have to order IP addresses, provision storage, install the application, and then start testing it out and rolling it out to users, buy licenses, and so on and so forth, right, to install locally. All you do is sign up for the service. You say, I want X number of users, and away you go. They sign in, and they instantly have access to that software. Same thing with Salesforce or Google Apps. It basically just gives you the ability to instantly turn on and have access to that application. All right, so if we look at the differentiators with these different groups of services, with IaaS, we manage from the OS layer up. From Platform, we manage from the data layer up. And then from Software as a Service, we basically manage nothing. All right, so here's just a graphic that kind of shows where these things fall. You can see when we're talking about infrastructure as a service, the vendor, I'll back up one, the vendor could be a third-party service, or it could be us as an IT department. If we're doing an internal private cloud, then we're the provider. All right, so if we're running a private cloud, then we are the vendors, and our customers are going to be the managers. If we're using a third party or a public cloud like AWS or what have you, then they're going to be the manager or the vendor. Okay, they would manage the virtualization, the servers, the storage, and networking. We, as the customer, would simply install our OS, our middleware, our runtime environments, whatever data and applications. All right, just want to make sure we understand that distinction. With Platform as a Service, the vendor manages all the way up to the runtime. So all we really take care of or worry about is the data and our application. And then software as a service, the vendor manages everything. All we basically do is consume the service, basically use the application. So I just want to make sure we understand the differentiations between. All right, and then we have different types of clouds. Okay, we have private clouds where we manage everything on internal resources. And that could be IaaS, PaaS, or SaaS. And again, it's basically boils down to, do you want to do everything? Do we want to manage soup to nuts from the storage, server, compute on up? Or do we want to have some type of a public offering where the cloud provider manages everything? Or do we want to have a hybrid where we have some resources are internal and then we have external resources or external cloud connectivity, so when we want to burst out or scale elastically, we can do so. So a lot of corporations are kind of playing around with which one works best for them. A lot of smaller companies just use a public cloud because it's easy. There's nothing to set up. A lot of larger companies that already have a very large or technical IT staff, they're developing private clouds, and then they eventually get into some type of hybrid situation where they're able to have their private cloud for whatever resources, applications, and so forth. But then as things grow, they have the ability, or at least be a broker of services, so that test dev or whatever the business users want, they go through IT and they burst out to the public cloud in a hybrid fashion, and then have access to one of a dozen or more providers, whichever one happens to fit the best and is the cheapest for that specific type of workload. And then we have a community cloud where we have resources that are shared among several groups or companies. And basically it can be public or private, but the costs are spread across all the members. So they're not necessarily in the same company, right? So they could be 3 or 4 or 5 or however many different groups or organizations, but they all have a common need. They all have a common desire for a specific application or a specific common interest. So they all pool their resources together, they spread the costs and share, and they use it together collectively. And then last but not least, I want to talk about layered security and defense in depth. Just real quickly, layered security and defense in depth, basically we're talking about two things. We have physical security, where we have guards, locks, cameras, badge access areas, etc. We want to make sure that we have not just a lock on the front door. We want to make sure we have locks on the windows. We want to make sure perhaps as we walk into our building, there might be a man trap so that they walk into the front door, but then they have to go through a second set of doors to get in. Then we want to make sure we have locks on our offices, right? We want to make sure we have locks on the data center. We want to make sure we have locks on all of our key areas, because simply having just one is very easy to breach, and once that's gone, there is no other additional line of defense. So cameras, badge access areas, just different areas that people have to pass through, so once they're in, they don't just have free reign of the entire area. All right, and then technological security, network access controls. We talked about ACLs previously. Desktop and server access controls, whether it be strong passwords or some type of two-factor authentication. Okay, role-based access control, basically giving people only access to only what they need. Antivirus, we need to make sure we have and is up to date. We need to make sure we have malware detection, spyware detection, and then our intrusion detection and prevention systems. All right, so you can see all of these things layer on top of each other. So it's not just a single pronged approach to security. We want to make sure we have physical, technological, all working in tandem to make sure we have the best defense possible. Okay, so a module review. We talked about a number of things here. Basically broke it down into some different areas. We talked about internal network security with our DMZ, subnetting, virtual local area networks, network address translation and port address translation, and then telephony, and how that really has the same rules applied that we do to our data networks. Then we talked about external network security when people are coming in from remote sites, whether they're teleworkers or branch offices and so forth, and then also network admission or authentication control, where we can quarantine systems until they meet a basic set of requirements to enter and access the network. And then we talked about virtualization and cloud concepts, IaaS, PaaS, and software as a service, and the different types of clouds that you will encounter, whether it be public, private, hybrid, or community. And then lastly, we talked about layered security and defense in depth. So I hope this module was informative for you. I'd like to thank you very much for watching.